Our solar system. 4.5 billion years ago, our star, the Sun, started its nuclear reactions and began to shine, giving us the opportunity to be here now. But in another 4.5 billion years, our star will reach its final phase, growing its size and luminosity in thousands of times. This will probably be the end of planet Earth, but also the beginning of a new cycle. This story is not about us. It is about dust. A star is dying somewhere in the universe. It is a mid-sized star, similar to our Sun. Its time has come to eject the matter to the interstellar medium, releasing to the empty space the molecules and dust that once formed it. It will do it in beating layers that pulse with the star winds, pushing the dust grains and the gas into a cosmic voyage. Most stars with masses between 1 and 8 solar masses evolve into the asymptotic giant branch stage, where the star cools and reaches a very large radius. This phase is characterized by strong stellar winds, which ultimately will create a huge circumstellar envelope of gas and dust, one of the most beautiful objects in the sky. But where and how were those dust grains born? The ejecta released by the star are composed by many molecules of gas and a small fraction of tiny dust grains. First condensation seeds can be formed in and near the stellar photosphere up to a few stellar radii beyond, where a high density is attained and the temperature is low enough for some molecules, most of them silicon and metals, to condense. The same condensation process adds molecules to those seeds, making them grow. Once formed, the dust grains are driven away by radiation pressure, entraining the gas with them, and when they reach the interstellar medium, they are processed by ultraviolet photons, collisions with energetic particles, and other physical mechanisms. Finally, dust will escape into the interstellar medium. Under some physical conditions, the surface of the dust grain will release the newly formed molecules, enriching the gas. Hence, this process changes the physical and chemical properties of the interstellar medium and controls its chemical evolution. In the coldest interstellar regions, cosmic dust grains play an important role. As they are coated by ices, they trigger interesting chemical reactions. The icy surfaces of those dust grains are the scenario where complex molecules mix and form. And as cosmic dust grains are the result of the star's death, the interstellar space is filled with the ashes of those dying stars. But maybe this is just the beginning of the story. The cold interstellar medium. There is where everything ends and begins for the cosmic dust grain. In some areas of the apparently empty space between stars, gas molecules begin to condense onto the surface of dust grains. This is the beginning of a long friendship where gravity and mass will determine whether new stars will form. During this phase, gas and dust allow an incredibly rich chemistry. If there is enough mass, clouds will collapse and we can have a protostar leading to a star with nuclear reactions. The life duration of the newly born star will depend on its mass. If it is supermassive, its life will be shorter. But if it is a low-medium mass star, it will live much longer. Those stars have time enough to develop a protoplanetary disk around them with dust grains fully covered of complex organic molecules. This disk will host the matter that remains after the star formation, the matter that, if the conditions are propitious, will finally form planets. This is a recycling story where every actor has an important role, and our main protagonist is the dust grain. Those cold areas of the sky where we can see stars birth, stars dying, and dark lanes have to be observed with radio telescopes like ALMA. Those are our eyes on the skies. Maybe, when you think about dust, the images that come to your mind are more related to the fluff under your bed or the layers of dust you can sometimes find after a long time without cleaning. But, for an astronomer, cosmic dust grains are at the beginning and at the end of every process of change in the universe. They see the basic building blocks, the cold universe, the seeds of stars, of planets, and going further, of life itself.